there's a formula that we're going to end up using that is called sine law. Now, for those that haven't seen this yet at all, keep in mind that your calculator has to be, you'll see up at the top, it'll be D, R, or G. You want it to be D or degrees. That is the angle measurement we are going to be using is degrees. Okay? Now, here's all that you need to know in this guy is that right now, the top is always some sort of side length. You need a copy too? Okay. Take the one off my desk. And the bottom is always some sort of angle. Okay? So, folks, while I'm talking, you're listening. I'm going over this thing here. Don't want to hear any chatter. So, side lengths on top, angles on the bottom. Now, for those that may have struggled with this in the past, the key to this formula is just that guy right there. I need to find a known pair. And what I mean by a known pair is angles that are opposite a side length have a relationship. Let's call those like pairs. So this 97 and that 7.9 are both known measurements, okay? And one is across from the other. Those two have a relationship. They are our known pair. So side length goes on top, angle goes on the bottom. Okay? Any questions on that? Finding that guy out there first? No? Okay. This is the most important part. Now we got to look for what is it that we are actually looking for. Let's start with finding the unknown x right there. So if I'm looking for unknown x, then that is a side length. That's going to go up top. That's a terrible x. Okay. That's going to go up top. What is it paired with? It's paired with the angle 48.4. Okay? So again, there's a relationship between side lengths and the angles opposite it. So sine 48.4. Now all I've got to do is figure out how my calculator works. If you borrow a calculator, make sure that like on the end of your exam that you're using like the exact same one that you've been borrowing from me maybe. But I would suggest getting your own because I can tell you right now there are kids that could have passed this course had they literally just bought their own $15 calculator and then found a process that worked for them. Because these are, I find this can be relatively easy and it's marks you're leaving on the table just by not buying a $15 calculator. So for me, I'm just going to remember how my cross multiplication works. I know I'm looking for x, so sine 48.4 multiplied by its diagonal, and then take that answer and divide it by what's attached. Okay? So if I'm looking for x, what's attached to it? Sine 48.4. Multiplied by the diagonal, so I'll be multiplying by side length and then dividing by sine 97. Now, Bradley and a few others, your calculators are wonky. You may have to do the extra step of turning sine 97 into an actual decimal. And if that's the case and you have to do that, that's okay. It just matters. Madison, can you stop talking? That'd be great. So sine 97 is, if I rewrite this, 7.9 over 0.993. You have to take it to 3 decimal places. Otherwise, I will mark it wrong. It's the only thing that I will use to mark wrong. Okay? It's the only specific aspect of the marking guide that matters. And the main reason is that sine 97, if I just took this to 1, it's, you know what I mean? It's not going to give me the same answer. It's going to throw off my side length just a little bit. And then x over, so sine 48.4 is 0.748. And again, I would walk through the same process with this guy here as well. That multiplied by the diagonal, divide by what was underneath it. And that should give me something like 0.748. It'll change a bit if you do it like full calculator versus that, but it's not that big of a deal. Times 7.9. divided by 0.993. And you should get something in the neighborhood of, I'm going to just round to a whole number and say x is equal to 6. Okay? Now, make sure you can calculate that guy on your own. Okay? I'm just going to pause this for a second and spin around. So here comes the hard part of this guy right here. And here's the only hard part. So if we go back to the same triangle, sometimes they'll make you solve the whole triangle, right? And so let's just say now we're solving for y. Well, it has a relationship with the angle opposite of it, but I don't have that angle. So how do I find that angle? I know all triangles add up to 180, so we literally just have to do one extra step. 180 minus 97 minus 48.4. That is going to give me this angle right here that I'm looking for. So 180 minus 97 minus 48.4, 34.6. 34.6. So now I have an angle to pair with that guy. I still have the known pair. This 7.9 and 97 is still the pair I would use. So in terms of setup to solve for this guy here, the first step is going to be the same. 7.9 over sine 97 is equal to x over sine 34.6. Again, if you're good with your calculator, multiply by the diagonal, divide by what's attached. So sine 34.6 multiplied by 7.9 divided by sine 97 gives me something like x is equal to 4.5. Okay? So that's the only added part of this guy here that would become complicated is if they say, solve for this guy, but it doesn't have an angle opposite it. There's going to be some way for you to find it. There has to be some way for you to find it. Okay? So that's finding side lengths with this formula. Any questions on that guy before I scroll down to the next part? Okay? All right. So that was side lengths. You can look at some of these guys here. We'll get into more of that later. Let's just talk about finding an angle now. So we'll start on this guy right here. So the same formula applies. It does not change at all, right? A over sine A is equal to B over sine B. The way we use it is going to be different, but when I look for an unknown angle, right, it's still the same formula, and I'm still always looking for a known pair. Known pair. I always have to get that before I do anything else. So the 15 and the 42. That's my known pair in this case. So I've got 15 over sine 42 is equal to, in this case, well, what am I looking for? I'm looking for that angle, not a side length now, but I know that angle is paired with that side length of 23. So I'm going to look for this angle right here, B. The only problem with solving for this B, I swear my B is terrible, is that there's that sign in front of it. It's going to add an extra little step here. But procedure-wise, I found my known pair, put it into the formula, and then I cross-multiply. So nothing really changes. Multiply by the diagonal, divide by what's attached to that. Multiply by the diagonal, divide by what's attached. That process is the same every single time. So 23 times sine 42 divided by 15. Oh, crap. Make that 16. Change this guy to 16. Yeah. Isaac, this is the one. You're supposed to catch this for me. No. Make that number 16, otherwise this one doesn't work. I gotta fix that. That's the one, yeah. Come on.
Yeah, Isaac, you're supposed to catch that.
No, he caught that before the break.
Yeah, you're supposed to make.
I was supposed to feel, I was gonna, yeah. I changed it on the Word doc, but I didn't change it on this yet. Oh, that's super helpful. Yeah, divided by 16. So we get sine B. Here's the one that's weird now. So that's 16 and not 15. Sine B is equal to 0.9 0.62. Okay? So that's not an angle. That's just a series of decimals to a hundredth. Remember to take 3 decimal places in this case, though, or three places past the decimal, if you know what I mean. So on your calculator, the one thing you've got to look for now, and mine says shift, my other calculator says second. Does anyone else have a button kind of like that? Usually the top left of their calculator. Shift, second. Are there any other options? Does anyone have an inverse button? Here's the second function. What is yours, Brandon?
Shift.
Here's a shift too? Okay. So, reason why you've got to click that is when you click shift and then click sine, your calculator is going to show something like sin -1. Right? This is basically the way we take that string of decimals and turn it into an angle. So 0.962 is going to give me an angle of, so shift sine 962, and I get an angle of, I'll just do it right here. We'll get an angle of, angle B will be equal to 74.2. So angle B, 74.2 degrees. Okay? So that's the process of this guy in terms of finding an angle. Okay? I'm going to pause this for a second because there's only one more thing to kind of go over with this, and then I'll let you practice these a bunch before we go anywhere else. Okay, I'm just going to go over one thing here with you guys is hopefully you're able to solve for this. So just eyeballs up here for a second because the end of your long answer question usually lands something like this. The last part of it. People go, I don't know how to get, let's just say this angle here. And in terms of like labeling what we just solved for, when I say B, I mean, that's just me using that placeholder. Like consider that almost just like an X. It's just like an unknown. This 46.3 degrees, if I want to write that properly, right? For those of you that weren't here for it and I didn't have it on the board, and maybe we'll go over it a little bit more later, we get back into proofs. But that angle would be written as angle BAC. And you think to yourself, that's kind of weird for them to put the 3 letters with it. But it's, when you stitch a bunch of triangles together, it makes sense that that is angle A. Okay, eyeballs up here, folks. I just want to show this one thing. Eyeballs up here because I want to make sure you know this because this is a part of it. There's some things that are more important than others. This is it. That angle right there would be BAC. You go first letter is where I'm starting. The middle letter is the angle, and then I finish it off. That identifies that that is angle 46.3. Now, on an end of your exam, this is when you get to the final triangle, it'll probably be something like this. And it'll say something like find angle C, where we don't have anything on this side length here. So right now, if you got to this stage of the exam and you solve for that, and so you now know that this angle here is 46.3 degrees. But they're actually asking in the end of year, give me angle BCA. So they're saying, give me that guy right there. How would you solve for that right now when there is no side length opposite of it? So that's the only thing where people will get caught. Technically, as soon as I get to it, well, not technically, as soon as I get 2 at a 3, I can find this guy by just going 180 minus the 72 minus the answer I just got. That's going to give me angle BCA. Okay? So the 180 minus 72 minus beauty, 61.7. So that would be this angle right here. That's the only thing that can get tough with these guys. There's one more aspect of this that I'm going to get into, but for right now, I'm just going to keep spinning around. So folks, we're going to continue on and do one more extra concept with this, and that is the problem with sine law. Let's look at these 2 triangles here first. Madison, eyeballs up here. is that sine law only likes to play nice with acute angles. Okay? The list on the board over there, you can see sine 30 is the same as sine 50. Sine 70 is the same ratio as sine 110. Because it returns the same value, basically what we have to do is when we deal with obtuse angles, we've got to do an extra step that gets kind of annoying. So this top guy here, right? If I'm looking for that angle, angle ACB, if that's the guy I'm looking for, and I set it up, put my known pair together, cross multiply, and I get 73.247. You're done. It's an acute angle, you're done. But as soon as I get into finding for an unknown obtuse angle, look when I plugged everything in. Same values kind of thing, right? But it gives me an angle of 73.247. This angle is obtuse. It cannot be 73.247. You didn't do anything wrong. It's just sine law is a little dumb. So we got to give it a little bit extra help. Sine law, for some reason, only wants to give us the acute angle. And again, we know why. The ratio just kind of works out funky. So that's basically it. One extra step when it's obtuse, 180 minus 73.25 is going to give you the actual angle value. So the unknown on that one, I think would be, what would it be if we just did the calculation on that? 73, 74, like
106.73 or 753.
75.
Wow.
Right? So you're just doing that. And if you're wondering why is that the case, look at your protractor. So now you all have one. This is 180. Straight lines are always 180. Triangles always add up to 180. Straight lines add up to 180. There's some cool videos on the internet about that if you're like bored on the like bus ride home and you want to look it up, like why is straight line 180 and why are triangle. Anyway, I digress. It's just giving you the acute angle. So in this right here, we're just going to subtract the acute to get the actual obtuse value. That's the only added part you're going to have to do. And you'll see in the booklet, where will you see this? You will see this on the end of your exam. And this is how you will see it presented. They will have it as a multiple choice. These two are taken from recent years. Okay?
So you just pair V with 216, 38 with...
You find it, do your subtraction, you're basically good to go. So I'll have you practice on these guys right here on your own. I won't go over them because I want to post this and do it from there. But that's essentially it in a nutshell. That is the problem with sine law.